So, all right. Measuring angles and arcs in a circle. All right. So, the first thing we're going to talk about is the definition of an arc, and I just kind of touched on that with you guys. It's part of the circumference of a circle, and it's defined by two endpoints. So I have, this is an endpoint, and this is an endpoint. I've highlighted that part of the edge of the circle, the circumference of the circle, right? So from this endpoint to this endpoint, how long would that be? So we can give that measure in degrees and in actual length. So this is also highlighted. This is an arc, right? We could have highlighted from here to here. We could have highlighted from here to here. Any part of the circle is an arc. There are no straight lines. Okay? We're going to make a note that the arcs can be measured in degrees and length. And you need to look for the words that tell us which one of those things to do. If they ask you for the measure of the arc, they want degrees. If they ask you for the length of the arc, they want some sort of unit of measure for length. Inches, centimeters, miles, kilometers, meters, feet, those kind of things. We define some arcs differently than others. So a minor arc is between 0 degrees and 180 degrees. Forget what this box is. Also, it's named by 2 points. So an arc got a beginning, we got 2 endpoints, right? Now, there's always defined by 2 endpoints, but they're not always named by only 2 points. So we could name this arc RP, okay, or arc PR, right? Let's look at a major arc. A major arc is between 180 and 360 degrees. It can't be 180 and it can't be 360. So anything over 180 and anything less than 360. The minor arc is the same way. Between these 2 values, anything more than 0 degrees and anything less than 180 degrees, that is by definition a minor arc. Now, why do we name minor arcs by 2 points and major arcs by 3 points? Well, we do that because, let's look at this arc RP. Arc RP is a minor arc. It does fall between 0 and 180 degrees, and we're going to know the actual degrees of that. But this makes sense, I think, to everybody. This line here is a diameter, and it splits this circle into 2 circles, or 2 half circles, rather. So we're not going to talk about that one yet. So if we're looking at this arc, right, and you've got an endpoint here and an endpoint here. If I go from here to here, that's arc RP. Well, why couldn't I call this? Oh, good. This is why I need my place. So this arc starts at R and ends at T, right? How do I tell the difference? Well, the way we tell the difference is how we name them, right? If we name it by 2 points, we know it's less than 180 degrees. And we can see that because this is the diameter. It's obviously less than 180 degrees, right? It would have to be more than 180. So the way we would name this major arc, if we're talking about this one, could be arc ROP, or arc RTP, or arc RSP, right? Any of those would work. That tells us, okay, it's not the RP that's less than 180. It's the RP that's more than 180. Does that make sense? Okay, and then a semicircle has to have exactly 180 points, and it's named by 3 points. Everybody wants to name the semicircle with the center point, but you can't do that. We name all of our arcs only by points that are on the circle. So when we name this, we're going to start on the circle and continue around the circle, right? Start on the circle, continue around the circle. We do not name any arcs by points inside the circle. Only by points on the circle, on the edge of the circle, okay? Now let's look at, any questions so far on this? Okay, so now let's look at this, central angle. It's an angle with its vertex at the center of the circle. So when you see central, you should be thinking center, right? This angle, RQP, is a central angle. Its vertex is at the center. Has to be at the center, right? So this central angle is 80 degrees. Now remember me telling you that the arcs can be measured in degrees and length? Here it says the arc, it equals the arc it intercepts. So what does that mean? Well, that means this arc that's created by the endpoints of this angle, right? So the two segments that make this angle, the endpoints on the circle, also define that arc, right? This is a central angle, and this is the arc that intercepts it. They have the same measure, all right? So this angle and this angle, or sorry, these degrees and these degrees will always be the same, okay? Remember that there's 360 degrees in a circle? Always exactly 360 degrees in a circle, right? So if this is 80, we know that this other major arc has to be 360 minus 80. Does that make sense? Okay. Now, what is this angle called? So this angle, 35-degree angle here, its vertex is T, and it's not at the center. So it can't be a central angle. This is called an inscribed angle. Oh, by the way, I'll put that in there. We talked about that on Friday as well. So the sum of, okay, so the sum of the degrees in a circle we said are 360 degrees, but we didn't really talk about what that means. So this circle, this 80 degrees, where this 80-degree angle is, the circle that's formed by these angles is 360 degrees. Also, the arc's degrees add up to 360 degrees. And that makes sense because the central angles are always congruent to the degrees of the arc that are measured in the arc, okay? But the inscribed angle, so this is an angle with its vertex on the circle. So you got to remember your vocabulary. Vertex means where the two segments meet to form the angle. That point is the vertex. So here, angle OCR has a measure of 35 degrees. This is an inscribed angle, and its vertex is not in the center. So we also have a relationship between this inscribed angle and its intersecting arc. They are not congruent. It is double. So this arc that is intersecting this inscribed angle is 2 times that angle. So 2 times 35 degrees gives us a 70-degree arc. That's the measure of this arc, not the length of this arc. Right? We're going to learn how to find the length of these as well. So if we knew this was 70, we could divide by 2 to get 35, right? Since we know this is 35, we multiply by 2 to get 70. Does that make sense, Harlan? Okay. Does that make sense, Gabrielle? Okay. I forgot what to put here. So central angle add up to 360. We already said that. And the measure of arcs add up to 360 degrees. So let's go ahead and put that in there too. I don't think we'll put the other part in right now. So you already have the sum of all central angles equals 360 degrees. But we need to know also that the measure of the arcs altogether equals 360 degrees for the same circle. Questions? Caught up with me? Okay. You don't have to to write anything here. This is just a recap of what we've done as far as the arcs. This was what was in our notes last year. I just pulled it from that. I told you guys we're redoing our stuff since we're using so much Alex. But so this is the same circle. What's the name of this circle? Do you guys remember what the name of these circles are? How to name a circle? Do you remember, Thomas? How do we name a circle? Mario? Are you talking about the arc? No, I'm just talking about the name of this circle. What's the name? How would we name this circle? Right. The center point here is B. We would name this circle B. And all these circles are the same. Right? So what is a minor arc in this circle? So as a recap, we've already talked about this stuff, but a minor arc is between 0 and 180 degrees. You don't have to write this down. You've already got it. It's named by 2 points. So if we wanted to name a minor arc in circle B, we would, the only one we can see is arc AC. We could also call it arc CA. Okay? They don't have points there, but they are endpoints. So the endpoints of the segments that make that central angle are also the endpoints of its intersecting arc. Okay? And when we write it, we can use the word arc AC or use a little arc over the 2 endpoints. Okay? A major arc. So, once again, you might be tempted to call this arc arc A, C. But then how will we distinguish it from the minor arcs? Right? So that's why when we name this major arc, we know it's going to be between 180 and 360 degrees. We have to name it by 3 points. So we can call this arc CDA or arc ADC. We cannot name it with just its endpoints. All right? And the same thing, you're going to name it with the word arc or arc over it. And a semicircle. You're going to be tempted to call this angle CBA, but it's not angle CBA. It's angle ADC or angle CDA. Right? We name the arcs by points on the circle. Right? Does that make sense to everyone? Okay. So one of the ways, some of the ways you're going to see this on today's assignment, in the circle below, A is the center. Segment BD is a diameter, and the measure of angle BAC equals 100 degrees. Now, we should know, looking at, what do we call this circle? What's the name of this circle, Maya? Helen, what's the name of the circle? Okay, so I'm not quite sure how we're forgetting it. We've talked about it 2 days. The center point, did you know that was the center point, Maya? Okay, so what's the name of this circle, Maya? Circle K, right? We're going to call it Circle K, like the gas station. It cracked me up. Thank you, Swan, for laughing, because I didn't notice on Friday at all. I'm making this thing, never noticed one thing with Circle K. Literally cracked me up second period. Nobody else thought it was funny. So I appreciate your sense of humor. All right, we should know that BD, segment BD, is a diameter if they tell us or not. Because it's a segment, its endpoints are both on opposite sides of the circle, and it goes through the center point. So by definition, that's a diameter whether they tell us or not. By definition, we should know that segment AC is a radius, because its endpoints are the center point and a point on the circle. Right? So we have to know those things. So can anyone give me a central angle in circle A? Can you give me a central angle in circle A? Darren? No. Can you give me a central angle from circle A? So let's look back at your definitions. If you're stumped, central angle is an angle with its vertex at the center of the circle. So where the vertex is where the two sides of the angles meet. All right, so look at circle A, Darren. This is the center. Can you give me an angle whose vertex is A? So you can't name an angle never can name an angle by 2 letters, right? So you gave me arc BE, I'm assuming, right? BE, that's an arc, right? We're looking for an angle. So an angle has to have two segments that meet at the vertex and create the angle. Devanshi?
Angle CAD.
Yes, angle CAD. Anybody see another one? Vivian, can you see another one besides CAD? Yeah, BAC. Okay, so the central point is A. Both of those angles are central angles. So either one works. Give a major arc. So can you name a major arc from this circle A? Xavier? Major arc. How many points do we name a major arc with? 3. Yes. And a major arc has to be greater than how many degrees? 180. Okay. So can you name a major arc from circle A? B, nope. So A is not on the circle, right? We don't name any arcs with points inside the circle. So we want an arc. Remember what an arc is, right? It's part of a circle. It's an arc-shaped line. Right? So A is the center. A is not on the circle. All the points of an arc are going to be on the circle. E, B, C. So do we know for sure? Oh, E, D, C. Yes, E, D, C works. So we know we're eyeballing it, but we're pretty sure arc E, D, C. Since this, we're kind of using a visual there, right? But we know for sure this is 180. If we said D, B, E, we'd know for sure because this is 180 here, right? So if you do E, D, that's less than 180. It looks like this is going to push you over 180, but if we want to be certain, we could say E, B, D, because we already know that's 180. Does that make sense, Xavier? So EDC, and I'm going to switch that. Let's switch that one. I would take that one. I'm not sure if Alex will take that one, though, so let's see if I can switch that. Let's do EDC. Sorry, EBD, my B. My B, D. There we go. All right, can you give me name a minor arc in this circle, Miles? Say it again. Okay, so how many names? So a couple things wrong. A minor arc is named with 2 endpoints, and those endpoints all have to be on the circle. No points inside the circle. Arc BE would be 1. Arc DC would be 1. Arc DC would be 1, and arc ED would be 1. All of those are minor arcs because they're all less than 180 degrees. Thanks, Maya. Okay. Now, can we find the measure of arc BC? So this is arc BC here. So what kind of angle is arc BC intersecting? How are you? A central angle. Very good. So arc BC is intersecting a central angle, angle BAC, and that angle measures 100 degrees. So what would the measure of arc BC be? 100 degrees. So the arc intercepting a central angle always has the same measure as that central angle. What is the measure of arc BCD? So BCD, what would that angle, what was the measure of that? Did I say angle or arc? Arc is what I meant, right? Yes, arc BCD. So if we go all the way around, what is the measure of that arc, Tori? Yes, 180. So BD is the diameter. It splits that circle into two semicircles, right? So it is 180. All right, we're going to go through the second circle K parts a little bit quicker. So this is circle K. It's the center point. Just take a gander at it for a second, then I'm going to start calling on people to give me the answers to these questions. Got points M, N, P, and L on the circle. The center is K inside the circle. All right. It tells us here that Ln is the diameter, and the measure of arc LM is 130 degrees. So can you give me a central? Can you name a central angle, Daria? NKM, perfect. Angle, NKM. Can you give me name a semicircle, Morgan? Mhm. Mhm. No. You want to start telling me then? Swan, do you want to try to help her? Oh, NPL, yes. NPL works. So this is the diameter. The diameter splits this into two semicircles, right? So it's going to be NML or NPL. Does that make sense, Morgan? Either of those. So this is the diameter. The diameter always splits the circle into two semicircles. Technically, I mean, if we had another segment with an endpoint here, we could name it, but we don't have that other endpoint here. Do you see the difference? That's why you can't start with M. You need to start with one of the endpoints of the diameter. It can be LPN or NPL, LMN or NML. Okay. How about a major arc? A major arc. Gabrielle, can you name a major arc in circle K? Perfect. MNL. So when we go from here, we've already gone 180 degrees, right? So that's 180 plus some more. So that's how we know that that's a major arc. Oh, and this is MNL, but that's, is that what you said, MNL? Gabrielle? Yeah. And can we find the measure of angle LKM? So the measure of angle LKM. So remember, it's been a while since we've done this. To identify that angle, start at the letters I gave you. LKM. That means we're looking for this angle. So LKM is a central angle because its vertex is at the center. So how can we find the measure of that circle, of that central angle, if we know the measure of its intersecting arc? Can you tell me, Thomas?
No.
Sorry?
Wouldn't it be the same thing as 130?
It would be. Very good. So the central angle and its intersecting arc have the same measure. And now can we find the measure of angle LPM? So LPM. So we're starting here. Let's get some of this off. LP all the way around to M. How can we tell what the measure of that arc is? Devanshi?
360 minus 130.
Perfect. We know that the measure of the whole circle is 360 degrees on the circle, so for the arcs and the central angles. So if we know this part is 130 and we're measuring the remaining arc, then it's 360 minus 130, which is 230 degrees. So far, so good? Okay. Caught up with me? All right, we're going to have to pop through a little bit faster. Last week, there were 225 students absences at Kennedy High. The circle graph below, I'll put out a pie chart, by the way, summarizes them by the day of the week in which they occurred. The central angle for Monday, for the Monday slides, is 56.6 degrees. How many absences were there on Monday? Well, we don't know about any of the rest of these measures. We know the slice for Monday is 57.6 degrees, and we know the total is 360 degrees. So that part of our whole 360 degrees will help us find the number of students that are absent. There's a total 225 students absent. So if we multiply the number by the fraction of degrees, the part over the whole, then we can do that. And for the sake of time, we're not going to write this part here, the circle. We're going to skip that because we need to move a little faster. So the part is 57.6 degrees, and the whole is 360 degrees. We multiply that by the number of total absences for this week. So this is the part of the absences, the fraction of absences. So on our calculator, we can literally just type 225 times 57.6 divided by 60 equals. Make sure you're in degrees, not radians. What'd you get, Elizabeth? Yeah, good. So this slice of the pie, this slice of the circle graph, represents 36 people that are absent on Monday. All right, any questions on example 3? Feel like you've done that before. In a recent election, there were 6 candidates and 4,300 total votes. So these are the candidates. They split up circle graph, 1, 2, 3, 4, 5, 6 parts because there's 6 candidates. They represent 4,300 votes. The table below and the circle graph both represent the same information, but the table gives you the percentage of votes that each candidate received. Okay? The question says, find the central angle measure, x degrees, for the Watkins slice in the circle graph. Well, that central angle is the number of angles out of 360, right? If we look here at the chart, Watkins, he earns 24% of those votes, so we can just take that 360 and multiply by 24%. There's a percent button on your calculator. I forgot where it was until this morning, but it's the second function on the 2 button. So 360 times 24 second 2 equals, you should get 86.4 degrees. Anybody get something different? So really, this one just requires you to be able to find the percent of a number. In order to find the percent of a number, we always multiply that number by the percent. We used to require that you convert that to a decimal and show that, but I don't care that you do that anymore. You got a percent button on your calculator, so just use it, okay? No reason not to. I want you to know that 24% is 0.24 or 0.24, but at this point, your calculator will do it. You need to know how to put it in the calculator. All right. There were 1,125 books sold last week at Sid's Bookstore. The circle graph below summarizes these books by genre. That means category, right? Kind of category. The central angle for the self-help slice is 89.28 degrees. So we're looking here at all the categories: romance, mystery, biography, cooking, and self-help. So this is a central angle here created by these 2 segments, right? What percentage of the books were self-help books? We're not finding the number of books, right? They make sure you answer the question they're asking. I realized when second period rolled around, I answered different questions than the questions we're asking in my case to build a flip chart. So make sure you're paying attention. What are they asking us? They're asking us for a percentage. Remember how to find a percentage. Percentage is equal to part divided by the whole times 100. So our whole is almost always going to be 360 degrees in these lessons, right? Because a circle has a total or a whole number of degrees is 360. So our part is 89.28 out of 360 degrees times 100. Literally on your calculator, 89.28 divided by 360 times 100, and don't forget to add the percent symbol. And you don't add the percent symbol on the calculator, just on your paper. So you should get 24.8%. Jatavia, making sure you're up and at 'em. Any questions on example 5? All right. Now we're going to learn how to measure the length of an arc and not the measure of the arc. So remember, the measure means we're going to get it degrees. The length means we need a length. We need to know is it 10 inches, 10 meters, 10 feet, 10 kilometers, whatever, right? It's got to have a unit of measure on there. And it's part of the circumference. Okay, so if we're measuring the circumference, we know the formula for the circumference is 2 times pi times r, right? That's the whole length around the circle. But if we want the measure of the arc, that means we want the measure of part of the circumference. So what part is that? We're going to use that whole part divided by the whole concept again. And I don't really like this angle measure terminology. I tried to tough it out today, but let's call this. Let's kind of change this to the arc measure. I think the arc makes more sense, in my mind anyway. The angle is not inaccurate, but we're talking about the arc, so I think we're going to use that arc measure instead of angle measure for our terminology. Okay. So remember, this is length, not measure, so no degrees. We're going to use degrees, but our final answer is going to be a length. The question says that the circle below is the center V, so that makes this circle V, right? And its radius is 9 yards. Given that the measure of angle WVX is 160 degrees, find the length of the minor arc WX. So go ahead and highlight your arc on your paper. And really what we need to know, what part of the circumference is this arc? Well, the way we find that is the measure of the arc divided by the total degrees in the circle. So in this case, if this is 160 degrees, what is the measure of this arc? Is this a central angle or an inscribed angle? Central angle. So the measure of arc WX would be what? Elizabeth?
That's what arc is.
I want to get, what's the measure of this arc? Yes, it's the exact same as the central angle. So now we know that the part that this arc represents of the circumference is 160 out of 360, right? So now we just have to plug in the other things. Now here's another little twist. Give an exact answer in terms of pi and be sure to include the correct unit in your answer. Remember, this is all length. There's not going to be any exponents on our unit of measure. So the formula is going to be 2 times pi times 9 times the part over the whole. Now, here's the other little catch. It looks like we're multiplying by pi, and we are, but we're not going to put pi in the calculator because pi, that symbol, remember, that's the exact measurement of pi, and we want the exact measurement of pi. So if we round it, if we replace that with 3.14 or hit the pi button that takes it out even more decimal, we're still rounding. All right, so our answer is going to have a pi symbol in it. So we're going to ignore the pi symbol right now. in our calculator, we're going to enter all the numbers. 2 times 9 times 160 divided by 360 and equals. So 2 times 9 times 160 divided by 360 and then the equals sign. We have to have the pi in there, but it's going to be, you should get 8 on your calculator, right? Well, this arc does not measure 8 yards. It measures 8 times pi yards. So everybody with your calculator now, I want you to put 8 times the pi button. 8 times the pi button. Is there a pi button on here? Where is it at? I lost it. Oh, right there, yeah. 8 times pi. And it equals, what did you get? No, you shouldn't have got 2.5. I think you should have gotten 25. What did you get, Harlan? 25. Keep reading all of them. Right, so take that on a bunch of decimals, and that's not the end of it. That's an irrational number. It goes on forever. For us to write that down, we have to round it, which means it's not an exact answer. Okay, so 8 pi is somewhere around that amount. It's not that exact amount. That's how we have to leave our answer. Does that make sense to everyone? Does that make sense, Darren? Does that make sense, Annalena? Annalena? All right, so here, remind yourself, you don't substitute any numbers for pi. Pi is going to be in your answer. So remember, 8 pi means 8 times pi. So that's why that works. All right. We're finding the length of major arc, LNM. It says the circle below has center K and its radius is 7 feet. Given that the measure of angle LKM is 60 degrees, find the length of the major arc, LNM. And remember, we're using the measure to find the length, but we don't have the measure of that arc yet. So we have the measure of arc LM. So how do we find the measure of arc LNM? Vivian? How are we going to find the measure of this arc? So remember, the measure and the length are not the same. The measure, hint, is easier. So 60 is the measure of arc LM. We want the measure of arc LNM. Very good. That's right. So we take 360, subtract 60. Now we know the measure of arc LNM is 300 degrees. So that is our part. This is our hole. We've identified the radius. So now we just plug into this formula. 2 times pi. Once again, they're telling us to leave it in terms of pi, so we don't substitute anything for that symbol. So the measure of arc LNM is 2 times pi times 7 times the part, which is 300 degrees out of the whole 360. So on your calculator, two times 7 times 300 divided by 360, and don't forget the equals button. Remember, we're not going to scan and submit our notes right now. We're going to go straight to working on a problem on our homework. Okay. We are going to spend 2 days on this, so we'll do today's assignment. Tomorrow we'll do a second assignment in class. What'd you get? Helen? 11 2/3 pi c, or 35/3. So I need to remind you guys how to use that button, because if we're given an exact answer, we see it around the fraction either, right? We need to give it as a fraction. So we're going to do 2 times 7 times 300 divided by 360 equals, I got the wrong thing. You should get 11.66666 and then around with the 7 to end. That's rounding. We don't want that. So you're going to hit second. Remember the very bottom button, the arrow button on the very bottom left goes from fraction to decimal and decimal to fraction. So press that and you're going to get 11 and 2/3. I'm going to put it in your calculator and see how to do it, okay? Everyone should be putting it in your calculator. If you put it in your calculator source, you get 11 and 2/3. If you hit second and ABC again, you can get the improper fraction. I don't care if you use improper fraction or the mixed number. Probably the mixed number is better in this real world situation because that's how we talk, right? We wouldn't say 35/3 p, pi p. We say 11 and 2/3 pi p. Probably more likely, right? Anybody have a question how to get that on your calculator? You can't do a decimal. Yes. You could do second and this second. And then it's going to turn to a partial fraction. Okay? Alright, we're now scanning and submitting. We are getting our Chromebook out and working a problem, finding the assignment, and working a problem.